Hi, welcome to the Spaceship Earth Mission Log podcast. I'm here with Carl Welty from the nature-based Zero Energy Air Conditioning Mission. And we are here talking about the Buckminster Fuller Institute Trim Tab Space Camp. We met on climate stabilization, and that was a really ambitious space camp, I think. And it's been great. I think Carl's mission is one of the most practical in terms of nuts and bolts of what we would have to do to get our world in a better state by design. So I want to talk to you about your mission. Let me do a brief introduction. Carl Welty has over 35 years of experience in the field of architecture. Carl is committed to creating architecture that connects human beings to nature, not as outside observers, but as full partners in the complex web of nature's closed-loop systems. Designing in partnership with nature means more than building efficient buildings that consume fewer resources. Wasting less is good, he says, but we can do better than just wasting less. Carl is a proponent of regenerative design, the idea that we can create buildings and communities that generate resources, energy, water, building materials, and at the same time restore habitat. So, Carl, welcome to the Spaceship Earth Mission Log. It's wonderful to meet you.
Thank you, Stephen. It's really exciting to be here, and these are very important questions, and always like to share these thoughts. And yes, I do think that I'm driven by both kind of big ideas, but also as an architect, finding ways to implement these big ideas into practical solutions.
Well, so I love it. What you're talking about is, in essence, passive heating and cooling. So this idea that the design of the building can create a habitable environment just via the architecture and use of nature. So where you're facing the windows, the angles of the roofs, the way that the concrete slab that's on the floor acts as a thermal,
Thermal
mass, yeah, because that concrete, it heats very slowly and it cools very slowly. So it releases that heat or that cool throughout the day or the night, depending on what you need. And so your project focuses on the goal of replacing the need for so much mechanical air conditioning, active electrical, putting carbon into the air. You said that by 2050, the estimate is that the world is going to demand 6 times the amount of air conditioning than it is currently using. And already it is contributing to 8%, I think you said, of carbon emissions plus, and that doesn't include the leaking coolant that contributes another large percentage as well, like 6%. So, yeah, this is definitely a trim tab, and it's one I'm surprised we're not putting in already, because ancient buildings didn't have electricity and air conditionings, but they stayed cool in hot climates. And so tell me about it. So you're an architecture nerd. You're an architect. You have your master's from Yale, right?
Yes.
You went to SLO for your undergrad in architecture, which is a great place to go for architecture. You have your master's in architecture, a great architect. I've seen your work. It's beautiful, beautiful work. Tell me about, how did ancient people heat and cool their buildings?
To date my ancient history, I became aware of this approach because I went to school in the late 70s and early 80s, college, undergraduate. And in the 70s, there was a really enormous international movement amongst architects to make buildings more energy efficient. And in the 70s, it was inspired by, I think, 2 ideas. One is the energy crisis, the oil embargoes. And also there was an idea that we would run out of oil kind of about now. And so, a professor of mine at San Obispo, who I've been in contact with recently, who's really been a national leader in passive solar buildings, but it was a real pioneer even in the early 70s, trying to make buildings more energy efficient. And something that they didn't have in the 70s was so much technology, like solar panels, electric, So they really had to solve it, or how to make buildings more energy efficient with simpler technologies, and they're just the building envelope, which is what the Persians did 2,000 years ago, or which kind of everybody did thousands of years ago. Another reference that I've recently discovered is Socrates talked about this very profoundly and would tell his students that, a good home faces the south if you're in the northern hemisphere, and shades, you use a roof to shade the building so you don't get too much sun and heat in the summer, but you let the winter sun in. So history is filled with really great examples of how to do this and inspiration of the principles. And I mentioned, like, one principle is keeping the sun out of the building in the summer and letting it in the winter. And that's easily done because the sun is lower in the winter and higher in the summer, which is something that all ancient cultures knew, that we kind of lost touch with the sun and nature because we have so much technology to heat and cool our buildings. But it's just, in closing, the way I think we think about buildings today is we make a box, and it's a well-designed box, a beautiful box, and we rely on technology, machines to create energy. And solar panels are now batteries and mechanical systems to heat and cool. But the envelope of the buildings remains just kind of a box.
Right.
And with a passive solar building, you think about the building envelope as an energy system. So you're using the same things. You have windows. You're going to put windows in the building. But you put windows in the right place so that it absorbs heat in the winter. And you use a roof overhang to keep the summer sun out so the building doesn't get so hot. And in California, it's very easy. And by venting the building at night, then you can cool the building and the thermal mass of the concrete. Maybe one way to think about it is it's like a battery storage, because it's absolutely a storage system. So in the winter, it's warmed by the sun, and it stores that heat through the evening, and then it slowly releases it, as you explained. And in the summer, you reverse it. So you cool that thermal mass off, that battery, that storage system off at night. And then in the daytime, it absorbs the heat, keeping the building cool naturally.
It makes perfect sense. I mean, it's almost makes you wonder why we forgot to do that in our modern work. And it seems like there's a lot of reasons, but things are just sort of slocked together now. I mean, there's these plans of architecture that are made and then carbon copied, around the world in ways that have zero to do with the environment. I know your architecture firm, one of your design principles is to connect to the local climate and to use that as a part of the architecture. And I think that's so important. I was thinking about one of your projects that you did in Santa Monica. It was a home. One of the design challenges was in the city of Santa Monica, the streets are at a 45-degree angle to north and south. So what you did was you created a sawtooth pattern so that you would have the correct north orientation for the windows, and it ended up creating a very unique design. But you had to overcome the challenge of all the streets running at a 45 to the compass, which, why would they do that? Is that just because where the ocean was coming in, or what?
It's I think the city, that grid, like in many modern cities, the grid is established by, I sort of imagine in Santa Monica, the first streets were more or less parallel to the ocean, and that's And in the cities, this is how cities often take shape, except for, because I love to talk about ancient history, most Greek cities built after 350 BC, after Socrates and other people talked about the importance of solar orientation, most Greek cities built after 350 BC were oriented correctly. Not north, south, or east, west. And there's even great examples of that they were able to orient the streets correctly in mountain areas where the topography didn't lend itself. And so,
oh, interesting.
And there's also Chinese cities were laid out. Cities in all cultures were laid out. It's pretty much universal, and it's not so hard to imagine because that's all they had: the heat from the sun, in addition to fires. But if you laid out your city in this way, you would maximize the benefits of both winter heating, but also keeping the buildings cooler during the summer. And so,
so they did it out of necessity, but for us, it's like just because we can overpower nature doesn't mean we should. And as you've mentioned, when you are in architecture that is oriented with nature and is a part of nature in a sense, it augments our experience. It first of all, it connects us to the cycles, the natural cycles of the world, which we've become very disconnected from. The moon cycles, the sun cycles, and it leaves us with this sense of like dysregulation. But also, beautiful architecture it warms your soul. Like when your architecture is connected with nature, you feel more at peace and you feel there's more beauty in your life. And so I think, everyone's probably had the experience of going into a building that is well designed and you just feel better. There's a sense of awe that happens. And I want, one of the things that you say is that we are not going to save our place on this blue marble if sustainable design is a luxury that only the top 10% can afford. So we need to make this accessible. Your architecture firm has a track record of consistently delivering 75% above the minimum standards for, say, like constantly LEED Platinum certifications. And your thing is like, how do we build this like actually more affordably than regular building standards? Like, tell me more about that, because I feel like that ties into your mission really well.
So if one pokes around and explores through the internet and their own investigation and about passive solar buildings, and there's this new certification called Passive House, which is sort of a German thing, which is a little different. But passive, what I call old school passive solar from the 70s. First of all, it's open source. There's no certification. And by many ways, I think it's simpler than things you have to go through to be certified. But one of the things you find in these sources that passive solar buildings, they achieve these really extraordinary performance standards, but without costing more.
Right.
So in the house that you mentioned in Santa Monica, my clients have used no energy for heating and cooling. But in Santa Monica, it's pretty easy if you just do these simple things.
You have the onshore breeze that's cooling from the ocean, and
it's
the
never,
temperatures are mild. It's never too hot, never too cold.
But in Santa Monica is an example of people say, well, I've been in Santa Monica for 20 or 30 years, and 20 years ago, we never worried about the heat. But now you get 1 or 2 weeks of the year where it's a little warm and you'd like to have air conditioning.
Right.
And so to make a building in Santa Monica that kind of takes the edges off those couple of weeks, pretty easy to do, because it's not 105 degrees, it's 90 degrees, but it's still cool at night. But my professor from college, he designed and built a synagogue in San Obispo, which is 15 miles from the coast and about the same temperature, almost identical to downtown Los Angeles. So it's much warmer than Santa Monica. And he built that synagogue in 2007. He finished, and he designed it without air conditioning system.
Wow!
And
a large public space without air conditioning.
And the construction cost was less than a typical building, and it was built with straw bale construction, which is highly insulated, lots of insulation. But because he's an academic, I have a doc where he tracked the temperature, the monthly temperature, and so he has shown that without air conditioning, it's kept cooler than a building with air conditioning.
Wow.
And in a discussion with people about, engineers we're trying to find, we're developing machines, air conditioning machines that are a little bit more efficient each year. But I would ask, a building without any air conditioning system, there's no machine that's going to get better, more efficient than no machine.
Right.
It's
Well, and why not do both? I mean, you could have an air conditioning and only run it 2 weeks a year, but if your building is the rest of the year, you're in a warm climate. The rest of the year, you don't need it, especially for things like heat. That's a huge net impact or trim tab as well.
There's a place for having a backup system, and actually one of my inspirations for my space camp mission was retrofitting older buildings. And it's say older buildings in California because it's easy and this is what I know. But probably 90% of the commercial buildings and synagogues and churches built in California before 1975, 1978 are like a synagogue that we belong to in Pomona. It's uninsulated concrete walls. And right before COVID, the rabbi and the people were talking about a large capital improvement to renew the building, and so their primary goals were to make the building more energy efficient, and also to bring natural light into the building because there's really no natural light, and so that's the
a big problem in a lot of buildings between
and this is how I approach, and I think the power of natural systems or passive solar. So I said, okay, so you want to make a building more energy efficient, and you want to bring natural light. But if you do those things in a certain way, then you're going to make the building extraordinarily efficient. And so I said, the first step is you have to insulate the building, which is part of my mission. And it's pretty easy to add insulation. I mean, there's cost, but you have to insulate the building.
Well, so what you do with a concrete, right? You're saying concrete walls?
Yes.
So you have an air gap that is maybe 4 inches, and then you have a layer of insulation. It's like you're creating
you can use pre-manufactured insulated panels, or there's the way to do it is rigid insulation that has a high R value per inch, and R value is the way we talk about how well an insulation works.
Right. It's sort of the thermal resistance, right?
Yeah. It's a 6-inch concrete wall has a thermal resistance of about 0.8.
That's not very good.
Heat transfers. So if you put 6 inches of rigid insulation on the outside of it, then you have an R30. So it's I'm not sure. One of the things we're looking at the analysis is to establish how much insulation you need on the outside. So R30 is probably way more than you need, and so you do that. And then I said, so these things you want to put on the roof to bring in natural daylight, if you design those in the right way so they're not just bringing in natural light, but also nighttime ventilation. So you cool the thermal mass off. So once you insulate it, all that concrete, which is a liability, becomes a really enormously great heat sink to absorb that. So it becomes a positive. And so I said, if you did that, then you probably would reduce your energy requirement for cooling by 50%.
Wow.
Well, but it gets better. So then I presented it to my old professor, and I got everything right except for he thought, and this is the guy who built the synagogue in San Obispo, he said you probably could reduce the heating load, the energy for cooling by 90%.
Wow.
And so in my trim tab of my space camp, I say, if we do this, if we insulate all these concrete buildings within 30 to 40 miles of the coast and you cool them off at night, then we can eliminate air conditioning. And that's so when I say 30 to 40 miles from the coast, it's probably a pretty easy thing to do. It's not a stretch at all. So compared to this building in Pomona, which is 50 miles from the coast, so and there's many other examples of buildings, people implementing nighttime cooling, thermal mass, and eliminate the need for air conditioning. So when I say 30 to 40 miles from the coast, I'm giving myself some padding. It's a pretty easy.
Well, and from California to Washington, that is a large portion of population. So that would be a trim tab. Now, so let's ask about your mission. Did you find collaborators for your mission? I know you said you were looking for help with marketing and finance and sort of the other side of getting this information out there. Who were your collaborators? What did you focus on, and how did that go?
Well, at this stage, the collaborator is a very interesting, wonderful guy who is an engineering background. He's an engineer from University of California, Irvine.
Very cool.
And he's been very involved in his position at Irvine is he manages research projects in various engineering disciplines. Richard Donovan. And
Richard, yay. Oh, yeah, I've heard Richard talk in the space camps in the group meetings. He's very well spoken, very engineering minded.
Very engineering minded. I'm just the architect who understands these principles. So it's very gratifying that Richard Donovan, he understands the physics of these principles, and the fact that yes, there's something to that. This will work. It certainly helps. But what I'm doing now is preparing a case study, a building type that then he can introduce to other professors or engineering students to do the analysis. So which the analysis would say, here's a building. This building would require this much ventilation, this many air changes overnight, and
Right.
require, R20 or R30, or so that's to be done, and also connect to Department of Energy grants.
Oh, very good.
I mean, of course, the Department of Energy is looking for ways to make retrofit existing buildings, because we all know that there's so many of them, and it's better to retrofit them than to tear them down to make more efficient buildings.
Well,
So
let's go back into retrofitting. Tell me more about, so there's all these commercial buildings, for example, that are just big boxes, as you say. And so you're talking about ways to bring in more light, and this is also in homes, but ways to insulate the outside concrete better. I mean, you kind of said the best building practice is just not build the way we're building. What kind of other improvements are you making at this point and looking to pioneer with passive cooling? Tell me a little bit more about that, because that's core to the project.
the idea to retrofit existing buildings, it's a problem that kind of in the green design industry, this idea of retrofitting existing buildings is difficult and expensive. And I like to say that if you are looking to solve that problem with technology, it's difficult. But
Right.
if you open yourself up to nature, or if you work with nature, it gets a lot easier. So taking an existing concrete building, which 90% of the buildings built before 1975 are these concrete industrial buildings, or
Yes.
it's probably closer to 95. Anyway, so it's most of them. And so there's this huge number of buildings in California that require air conditioning, or start to require more air conditioning. But so if we retrofit them, insulate them, provide some ventilation, those buildings are good for another 100 years and will not need air conditioning.
Wow.
I mean, 100 years
I'm
is,
thinking of like the entire city of Orange, which is all industrial buildings, like the one in your slide presentation, giant rectangles that are
it's,
just sprawling out everywhere.
in addition to the insulating, the venting at night, if we also start to incorporate, think about the landscape, consider the landscape as part of the energy system.
Oh,
So
yes.
in comparison, so now in Orange or in much of California, there's some of these buildings have lawns and landscaping, and there's this sort of detached idea that we can replace the lawns and with native plants that use less water. So to add to that idea, if we're going to retrofit those lawns or change those lawns to a landscape that uses less water, what I would say, okay, but this is systems thinking, right?
Yeah.
This is like perfect. I mean, great systems thinking. So instead of just thinking about replacing the lawn to save water, think about that landscape as part of the energy system. So
Right.
you use trees to shade the building, on the west side, because the western sun heats up a building. Even the windows, the western sun will heat the building up. Even if it's
Yes.
insulated, if you shade it, you just start doing these things that will increase the performance. And then
Right. Well, you
also,
mentioned deciduous trees. If you're trying to let more heat through in the winter, use deciduous trees, because they're going to lose their leaves, and that heat is going to come through when you need the warming. And when it's the summer, they're going to have leaves and they're going to shade more.
yeah,
Brilliant.
it's and that whole, and I would say that as we start to design in this way, it starts to increase our awareness of how part of nature, these natural systems that are surrounding us. And I mean, the other part I think that's possible with retrofitting these buildings is, okay, if you're going to create a landscape that helps reduce the energy, that new landscape could also, you can create outdoor spaces, sort of flexible workspaces or outdoor
Right.
lunch rooms. Like a little detail thought is, and this could be done in larger buildings. If Google people are hearing this, even large office buildings, you
Right.
could, you can. I mean, like if you have a 6-story tower that's all glass, or a big building, I mean, you're not going to grow a tree that shades that. But if you created a landscape outside that building with good foliage and some, maybe a water feature that will increase the moisture, you could
Right.
reduce the ambient temperature outside the doors where people are going in and out all the time. So
Right.
so if you could reduce the ambient temperature 10 to 15 degrees at the entrances, So when that air moves into the building, it's cooler. And the ancient example of that is Moroccan courtyard houses or courtyard houses throughout the Mediterranean, but even in the
Mm-hmm.
hot North Africa, Morocco and Tunisia. The traditional housing, or courtyard housing with lush planting, a water feature, and courtyards of those gardens are 10 to 15 degrees cooler than the street temperature. And that's
Wow.
keeps the houses cool. And then a more,
That's significant.
it's
And then
enormously
and then
significant.
people who are walking in and out aren't reaching for the air conditioner trying to turn it down because they're coming in feeling cool already.
Well, and so that cool ambient temperature in the courtyard is, it gets pulled through the house and keeps the house cooler. So in a modern example, there's a development in Davis, California, which is a very hot part of California. And it was built between 1975 and 1981. So this is another example of how clever some of these people in the 70s were designing things that still outperform our new things.
Right.
So village homes, which in there's much written about it. So they designed the city, the development, starting with nature or ecology and natural systems, which are how the sun moves across the sky and how the water moves across the land. And so they designed this human community starting with that, not a geometric order across the landscape. And so it's extraordinarily impressive. But because of the integration of buildings, street widths, the landscape, capturing stormwater, which is they did this in 1975, capturing stormwater was not mandated in California until 2010. And so Village Homes is probably 20 years older than any permaculture garden. So the
Wow.
soil's been gathering water for now almost 50 years. But so the energy benefit is that the ambient temperature in Village Homes is 10 to 15 degrees cooler than the rest of Davis, and that
That's
people are now.
significant.
It's yeah. I mean, so if it's 105 degrees, if you get it to 90, and then the buildings are designed for nighttime cooling, getting that temperature down 10 to 15 degrees combined with good passive solar design, another result is that people still don't have air conditioning, and so
Wow.
so
That's
and
incredible.
it's really incredible. And these houses are now almost 50 years old, and another resource efficiency or cost efficiency of this is, so these people, in theory, they didn't have an air conditioning system that had to be replaced 2 or 3 times since it was first
Right.
built. And so
Right.
the
And all
cascading of
the
benefit.
waste that happens because you're just throwing away the old system and you have all the old coolant and
And the leaking of the
financial.
refrigerants.
Yeah.
Yeah. So the house without machine is not leaking refrigerants.
Yeah.
It's really,
Couple things.
and it's
Yeah.
so extraordinarily simple. The social benefit of village homes is people have more friends. A walk out into and nature is just walking outside your door, and there's fruit
Yeah.
trees, and it's an example of what people are talking about, what we need, and it's a 50-year-old example. So it's kind of points how to do it, and also demonstrates that all these systems are very resilient. Yeah.
Yes.
So
Couple of
it's
things that brought up when you were talking about thinking of the architecture of the outside and the landscape as like a part of the system. When one of the things that Bobby Fishkin's crowd doing is researching is around biophilia in like hospitals. And the idea that being connected with nature increases measurably well-being. And in a medical setting, they were talking about even in reducing medical accidents and increasing the rates of healing, like measurably. And so there is a really important quality of life consideration that comes along with having trees and plants and nature as a part of your living system that you're living in, as well as you mentioned the social aspect of people going outside and intermingling. And I love that you mentioned water features, because in California there's this sort of thing that's happening that everybody turns off all their fountains because we're in a water crisis. And what you mentioned was actually bringing that moisture into the air. The plants use it, they respirate it. It's lowering the temperature of what's coming in and out of the buildings, which is reducing heat exchange. And so if done in a symbiotic way, the water features are actually a really important part of the ecosystem that you're restoring. And your building that I mentioned, the house that you built in Santa Monica, it had a cistern for capturing, and you were reusing that water for the plants, so it would capture rainwater into. Why don't we have cisterns now? Like,
I hate to be, I don't want to be contrary, but
why aren't we building this way? What has gone wrong?
Well, one thing I learned from another project that's on my website, it's a water education building, and there's some really great qualities about that building that I can share another time, but the building connects people to nature in a more metaphysical, spiritual way. But we had many conversations about cisterns and the benefits. In a nutshell, if I were to build you a concrete cistern for your house in Southern California to collect the water from your roof, the amount of embodied energy in that cistern is significantly more than it takes to pump that volume of water over 20 years or 30 years over the grapevine.
Right.
But if you're building a cistern in Arizona, there's 2 rain seasons. To capture 20,000 gallons of water, you need a cistern that's half the size because you get your rain twice a year.
Right.
So there's a balance in California of cisterns, because we just get water. I kind of, in summary, I think, I'm not saying no to cisterns. I'm just saying that, having that question that we discussed in part of that project, it's a conversation that should be part of this conversation about cisterns and water. The water feature, you talked about turning fountains off.
Right.
Because we turning the water off because we just think about fountains as a water luxury.
Right.
But so then you realize, well, that water can be part of the energy system. So somebody with more math skills than I have could look at, so a well-integrated water feature helps cool the air off a certain amount, which will offset the energy by some amount. So then you could do some analysis. So the water feature is not just wasting water, but it's also saving energy.
Right. Yeah, you have to look at the energy exchange as a whole. Reminds me when I was talking to Lauren Minnis about the 8 forms of capital. And you don't just look at money, you look at human experience, and you look at natural systems, and you look at all these different things that are all part of the whole energy system. And, I guess if your fountain is in the middle of a concrete area where there are no plants nearby and it's not by a door, I think that's the problem. I think the fountain's just there to be a fountain. Someone wanted to look pretty.
So, whether we're talking about fountains or the building pattern or, it's thinking about it holistically. And a fountain in the middle of a concrete corporate plaza, that's not going to do anything. But if that fountain is closer to the door and you have some planting around it, then it will contribute to reducing the temperature of the air that flows into that building.
Yes. Well, the other thing about trees is that in neighborhoods, a lot of people nowadays, they'll buy a house and they'll cut the trees down because they don't want to pay for the arborist. And they think, oh, well, it's gonna grow toward the house and we'll have to get it cut. And so I'm seeing this trend of beautiful, mature trees that are 30, 40, 60, 80 years old that are just getting felled. And, all these new developments, they're designing them without trees or with minimal trees. They're all brand new trees, so they don't provide any shade yet. And that's a really sad trend as well. I see, trees getting cut down like crazy in neighborhoods.
So Village Homes in Davis, they just get so much right. So the trees provide shade, but because they've designed the landscape or the topography to direct the water to swells and off, so they wouldn't have to use so much water for watering the trees. So just one thing I really love about Village Homes is because the drainage system, how the water moves across the site, and they designed it with nature, so they didn't have to buy concrete drain pipes, which represents infrastructure that we're trying to environmental design. You want to reduce the infrastructure. So they completely eliminated the infrastructure that we use in all of our developments, the concrete drain pipes. And there's so many great stories about Village Homes. So they, in 1975, they saved $200,000 because they didn't have to buy the drain pipes, and they bought 300 fruit trees.
Oh, wow.
So no concrete pipes. You get 300 fruit trees. So now the fruit trees are mature, and there's a great article from Jeff Lawson from the Permaculture Institute in Australia. And it's a great article from 2013, which includes 2 videos. So he's saying, he's never been in a permaculture garden where there's so much fruit. And like he says,
Wow.
he's eaten all the fruit on these trees, and he said, I haven't had one bad fruit. And of course, because
Wow.
the soil they've been capturing stormwater for 50 years. So I make these grand declarations, but the soil is probably the healthiest soil, certainly in a human development, because it's been absorbing water for 50 years now. So
Wow. Wow.
so the trees are healthier, but that healthy soil, that moist soil, increases the moisture, and so that absolutely contributes to the ambient temperature being lower. So village homes, they just got the biology right, and
Yeah.
now we can look at it 50 years later, and these are all the benefits. There's on the social, like the natural connection to nature part of it. In this video from 2013, they have a young 10-year-old boy talking about like, oh, there's so many places to play, blah blah blah. But then he says,
Yeah.
and there's fruit all year, and he says in December we have pomegranates.
Yeah.
And for me, it's extraordinary. So this 10-year-old boy knows that pomegranates are available in December, which is, I mean, it's a beautiful example of
The fact that 10-year-old boys don't automatically know that is concerning.
Who knows that?
Or
I mean,
should be concerning, because and thinking of the nature as a part of the development is, I think, where everybody wants to go. I mean, how do we get away from that? I want to talk about linear Renaissance perspective, and you
well,
like
let me
to
just
talk about.
think about cutting down trees. So I think that village homes, some of the lessons in village homes are adaptable to retrofitting, because like as you said, there's these, one of the things that people who have written papers about village homes or looked at village homes, we all ask, why aren't there more of these?
Mm-hmm.
And there's really two developments in California. One, village homes in 75. There's one in Claremont built in 87 that got the streets. The streets are oriented to the right direction, and they used the natural slope to capture stormwater. But why aren't there more of them? So the lessons of directing that rainwater to trees will increase the soil health, but also reduce the need for watering of trees and improve the resiliency of the trees because they're getting a deep water. So there's lessons from village homes that can be incorporated into retrofitting of buildings and homes. But anyway,
Yeah, but when you have a industrial park with corporate land management and building systems management, who's stewarding the nature in a holistic way? Someone decides, oh, we just want to change this because everyone's going succulents, so we're just going to tear out all the trees. And they're not thinking from a systems perspective. And there's not someone on site who cares about the ecology and the well-being, and all these things are working together. I think it could be just part of our financially centered model of myopia that is causing, the current systems that exist only to optimize parking spaces, or, let's say, vandalism and theft, those kind of things.
One of my mottos is in village homes proves this in many ways, is that these natural systems, if you work with nature, you're going to make a building that's 70%, easily 50% better than normal without increasing construction costs. So it's cheaper.
Yeah.
And village homes cost several $1 million less to build, so that passive solar home that's heating and cooling itself is more resilient. So even if there's a power outage, it's going to provide thermal comfort. And that's an important issue now. So I believe very much that these natural systems, and this is pretty much my work, and people who are interested in marketing and can hear this. So these systems, this approach is, to be oversimple maybe, but it's cheaper, more efficient, and more resilient. And so this is the part about the point that we're not going to save our place on the planet if only the top 10% can afford it, or if sustainability is a luxury, which is now, for the most part, people
true.
think it's a luxury.
Yeah.
And there's many reasons why that's our economic system.
The Spaceship Earth Mission Log podcast will be right back after this preview from the Language of Creativity podcast.
Coming from a fascination with science and the physics and the mystery that's unraveled over the human history, how the human mind is always trying to figure out, like, why does this work? Why did that fall? Where are we in space? getting a microscope and finding out that things are not solid and there's things inside of themselves. And I did have the experience of working on Powers of 10, a movie with the Eames office with Charles Eames. And I was a painter for that. And so I got to experience before a computer, three-dimensional computer, and be able to build things with numbers and understanding fractals and all that stuff. Before any of that, his vision was to show exponential numbers. Like, how do you explain it? And so his idea was, let's go 10 meters for every 10 seconds visually from looking down at a blanket in Chicago of a couple and then going down into the hand and then through the skin.
Oh, that Powers of 10.
Yes. And
Whoa.
and going down into the molecular and the atoms. And that time, our knowledge was we discovered that quarks existed. And so my job was to visualize from the skin cells and molecules into the atomic structure and to the level of a quark, and as 4x4 paintings. And so, never having really finished any academic college, but an art college, my learning came from mentors, that physicists that would come and explain everything to me, because there were no computer drawings of things.
Wow.
And so I was a conceptual artist, visualizing things that we could only imagine mathematically through science discovery.
People think of architecture as a luxury. I think that's why everything's so cookie cutter. It's like, oh, we can save money because we only have to hire the architect once, and then we can just throw it on whatever land we want.
And if I can slip into this, and also we think that green architecture is even more of a luxury.
Yeah,
it's going to increase my construction costs. So this is what's so important about passive solar, is that you're getting 50% or better more efficiency. And it doesn't cost more because you're just putting the windows in a different place. You just, you're using the things that you're already paying for: windows, roof overhang, concrete. But you just combine it in a way that they all work in unison as a system, not just an envelope that's not doing anything.
Yeah.
So that's if there's any one takeaway here is that this natural approach is cheaper, more efficient, and more resilient. And I'd love to talk to anybody who wants to hear how that works. So anyway,
Tell me more about linear Renaissance perspective.
So quickly, my personal experiences, when I was in architecture school, we were taught to draw perspectives by hand. Now it's all on a computer. And not just in architecture school, but in our culture, we're very much taught that Renaissance perspective, and the perspective that is sort of proven that it's correct because of our cameras. We're taught to believe that that is how we see the world. And for me, towards the end of college, because I was reading more history than maybe I should have, I came across this great point, which is perspective. Those rules of perspective were invented in 1413. And so my naive 22-year-old mind thinking, well, if it was just invented by one person, it doesn't mean it was given to us by God. But so then, so as I explore this question, you start to see how it immediately changed how we make architecture and urban design.
There was immediate change in the way that cities were built.
Yes.
And there were tools and machines developed for people to look through these little windows so they could see the world in lines going to a single point in the distance.
Yeah, so that's the in
people
Western
became
perspective.
Obsessed about building everything in these lines, in these parallels.
Yeah. So the machines. This is kind of, I guess, the book that I need to write, which is this history of perspective and perspective machines. So European artists and culture became really obsessed with these machines that use these rules. And what's had happened is between the first perspective machine from 1500 by the Dutch painter Druer to the camera, and now we have artificial or virtual reality. All these machines that are just this history of we're always looking for a machine to record nature more accurately. And I think that for me the reality is that these machines don't. What we fail to understand is we keep making the machines to be more accurate, but it's using the rules that we invented. So there's this circular logic that, a machine proves that it's true, but the reality is that these are the rules that we invented. And then inversely, outside of the success of European colonialism, pretty much every other culture their mode of perspective or mode of representation is different. The models I like best are Chinese landscape painting or Japanese painting. So it's easiest to describe as it's multiple perspectives, and there's a sense of time element to it. And there's a beautiful
Yeah.
idea from a Chinese landscape painting requires the viewer, to imagine themselves floating in nature, like part of nature. So
Yeah.
versus in Western perspective, it's about looking, it's man in the middle. It's all reference to man, and you're looking out over a landscape or a naked woman through a frozen window, frozen in time.
Right.
So I think that within the language of these other drawing languages, there's necessarily a language that is about man as part of nature, not separate from nature.
Well, I was reading about Chinese landscape painting, and what they said is that as you roll the scroll, you're you're traversing the landscape. So the format of the painting being unrolled invites you to walk across the countryside. And so there is that element of time unfolding in the art form. And the Chinese painting specifically uses the 5 elements. So there are certain things that always go together. There are things that never go together. And there is a sense of the proportions are also creating a sense of emotion and emotion and an experience. And so it's not necessarily to portray the most accurate mountain that you could use as a map, although maybe you could in some way. It's more about the experience you would have had or the imprint you would have had of going to the place.
Yeah, so this is one of something I like to talk about, and sometimes it's controversial, but I'd like to talk about how modern art, Picasso, was influenced by Chinese painting, which is
interesting.
Which is many art historians today, even today, the idea that Picasso was influenced by Chinese landscape painting is sacrilegious. It's, because the history of Picasso and the history of European modern art, it's about, to use Picasso as an example, Picasso, here's this brilliant man who invented everything. But the reality is Picasso's a man, and he was inspired by ideas started by the Impressionists, which is the things you just talked about. They wanted to create the emotional response.
Yes.
It's not just the most accurate color, but it's your emotional response. And there's much written about this, but the idea that you can make a painting that's not the correct view, but it has a quality of emotions. They learned that from the importing of Japanese and Chinese prints from the early, middle of the 1800s. So there's historic. So they were influenced by it because they started to see them. In modern architecture, Frank Lloyd Wright is sort of considered the beginning of open design, but he was influenced by Japanese prints. There's a really important book for me. It's a great title. It was written by a Yale art historian. She kind of encapsulates the core value or the core goals of 20th century art.
Yeah.
The name of the book is Non-Euclidean Geometry in the Fourth Dimension, Early 20th Century Art.
Amazing title.
And so, but her thesis is that of all the isms, Cubism, Futurism, Constructivism, they were all interested in 3 things. A sense of time. And their sense of time is not just passage of time, but that's good enough to understand. So the passage of time, like what you talked about in the scroll, or just even looking at a Chinese print flat, you're moving around the space. So
you have to your eye has to wander through the scenery.
Yeah. So there's time. Non-Euclidean geometry is sort of geometry on a curved surface or something more intuitive, I think. And the third thing is a critique of Western perspective. And so this is one of the books that I came across very early on. It gave me so I'm not a crazy person. There are other people writing about this.
Yeah.
And so I had this conversation with a woman who was from China, and I said Picasso was influenced by these things. So she had this chart comparing Western art to Chinese art, and it's like Chinese art has time, multiple perspectives, and there's a transparency. And I said, so she had this chart, and I said, if you just took your chart and scratched off Chinese art and wrote Cubism, or Western art being Renaissance art, I said your chart is completely the same. So that the fundamentals of Cubism is time, imagine a space that's not so organized.
Yeah.
And so it's completely parallel. But there's this great interview from Picasso from the 30s where he says, nature's everything. And just like Picasso is a naturalist, so he says nature's everything. Like we can't do anything better than nature. And he said, so the artist's role is to connect his nature, your internal nature, or I think intuition, to the outside nature. And so linear Renaissance perspective is something has shaped our culture, our interest in measuring nature, objectifying, making nature ascribing a logic to it. And so this is how, so instead of like Village Homes, where they started with the biology, development in architecture starts with geometry.
Yeah.
And so the first Renaissance space was built in 1459 for the then Pope. So from the very beginning, this idea of creating a symmetrical space outside of a church or a palace, the very first time it was done, it was by the Pope, who was not a friend of the common people. So from the very beginning, this idea of this very rigid geometric order was used by people like popes and Hitlers and Napoleon, corporations, to project power. And it works because we in the West, we think of geometric order as sort of, it's not chaos, or it's
there's this saying that order is close to godliness, and so there's this idea that the order, the rationality, the clean lines and everything like that is a sense of more evolution and better. And then nature and messiness and things that just sort of emerge and go every which way, that's sort of the dark other. Like, we need to tame nature, we need to carve a line through this, we need to trim the garden and make it all,
Well, so I like the way you said it, because with systems thinking, we start with, nature's messy. We have to accept that it's not a grid. It's so that all these
it's
complex...
following an emergence. It's emerging from a pattern, but that pattern is influenced by, it's a lot more like fluid dynamics when you watch the Coriolis effect. I mean, all the things is like predicting the weather. They're all affecting each other, and it's chaos theory. It's not clean lines in parallel.
That's a beautiful example. And so again, Village Homes, they didn't start with the geometric order. They started with all these systems thinking. It takes some subtle thinking to understand how these forces work together. And if you work through that, the result is always cheaper, more efficient, more resilient.
Yeah, and let's talk about Cubism for a minute, because Cubism is a very abstract form of art. And I think what Cubism is sort of accomplishing is this extra dimensional perception. So you start off with the locus of there's more than one perspective. And in this canvas, there's more than one perspective, and you're taking it all in simultaneously. So I think in a way, it's training us to think beyond linear time, beyond linear spaces, beyond a single perspective. And to see in that, I'm reminded, you mentioned non-Euclidean geometry. There are non-Euclidean video games that people are developing.
Really? Oh, I looked at
yeah, you should check it out. Games like Hyperbolica, and there's another one called Antichamber, and then there was one called Superliminal. And what they're doing is they're playing with different senses of space and time, and things aren't going to a single point, and things are stretching out in absurd ways, and it's a mind bender. A lot of them are really, really and you could do this in the VR space. So it's sort of like you said, getting away from that assumption that we have an X, Y, and a Z coordinate in terms of geometry, and really playing with that, bending. I mean, one of the most famous non-Euclidean game, which I would say doesn't bend the points very often, but it's called Portal. And in Portal, you shoot this portal gun, you open a portal here, and then another one over there, and you can walk through it and come through the other side. So you can do all these incredible physics puzzles where, well, what happens if you put one portal above the other? Well, then you can reach terminal velocity, because you'll just keep falling through the
Well, that's exciting, because I'm totally outside of the video game world, but I always wonder, like, why there are so many video games when the computers can be so powerful, but we fall back to this linear perspective thing that's so limiting in our understanding of how natural systems work. So
well, and I mean, that's why I wanted to kind of harp on this point of linear geometry for a minute. It's useful. It's very true in photography, where you're taking a 3D world and making it in 2 dimensions from a single lens or perspective. So there are reasons why, but once you pointed out to me through your research that this had changed everything after 1490, whatever it was. Yeah, after that point, like literally all architecture changed, all city design changed, everything was on this grid or this geometry. And the worst example of it are the streets in places like London, where literally there are buildings on either side and it's like this rectangular street and there's no way out. There's almost, you could barely see the sky.
To be a smarty pants architect, actually Paris is the epitome of it.
Ah, okay. Yes.
And so Paris, these grand boulevards of Paris that are all connected, and there's a church at the end there's an obelisk at the end. That was Napoleon's Paris, and Napoleon. There's one of my favorite quotes from Louis Obispo, who's wrote about kind of humans and cities from the 30s, but he said, he wrote that Paris came about from 2 things: the Napoleon's need to march his armies down large boulevards, and Renaissance perspective.
Yeah.
So part of the history of perspective is there's 3 paintings from the early 1400s, middle 1400s. They're called paintings of the ideal city. And so this is artists playing with 1-point perspective.
Yeah.
And if you're an artist playing with this new thing, 1-point perspective, you're going to draw a city street, and the buildings are the same side, the same dimension, the same height on both sides. And then you're going to put an object at the end of it. So this is the conceptual beginning of Renaissance cities and Baroque cities.
Right.
And so Paris, so in Paris, Napoleon laid out this really rigid geometry over the medieval Paris.
Yeah.
And we still do that. We lay out a geometric order over the landscape.
That's exactly right. I mean, the landscape's curving and bending, and then what do? We bulldoze it. Yeah. So
there's also a common practice now in suburban developments is they curve the streets to make it look like nature, and it's not nature.
They're not actually going with the existing curve of the land. They're just like bulldozing it to curve.
Yeah. In a project that's development in Claremont I looked at. So oftentimes these suburban developments with the streets are all, they're curvy, and they actually require, because if they ignore the natural slope, they're going to require more infrastructure, more concrete drain pipes to make it work.
Right.
So for me, the connection to art and cubism and or thinking more in more complex dimensions, that allows us to start to, if we use that as a model for looking at nature, it will help us. It has helped me see these complex systems with more clarity. Because I also can't help. Probably the most important artist to me was a Russian painter, early 20th century. His name is Lissitzky, who is probably he's considered the father of 20th century graphic design. It's like what we think is 20th century graphic design, like the word as an object and sort of transparency. It's Lissitzky, but he in his writings he said this thing in the 20s, so now 100 years ago. He said, he tells people perspective isn't real, it's just a system. And this might part of my story here, my logic. I'm just stealing it from Lissitzky, but he says, so people, I would say this to people, and people like Lissitzky and Picasso, they were all saying this, perspective isn't real, it limits us. But he said, but Lissitzky writes, he said, but people will say, oh no, of course it's true. The camera proves that it's true. And so then he would say, well, no, it's just the lens. It looks like it's true but the lens is based on our rules. So the point is, all these machines seem to show that it works, but it's only works because it's from the rules. And this is what we forget. I think we don't understand is that we incorporate machines in our lives, and we think they show us the truth, but we forget to look to realize it only looks like the truth because it comes from the same rules that we invented. And then also, I know we're so, and also Lissitzky, he says, again, 100 years ago he wrote this. He said, "There's a Chinese camera lens where it works like a Chinese perspective, which the cone goes out and not in."
Mm.
And when I read this in the early '80s, I'm thinking, well, that would be a great doctoral thesis. Like, how do you find this old Chinese lens that goes out and not in? And like 5 or 6 years ago, I realized with Google, like, you can find it, but they're available and you can buy them.
Wow, that's so incredible. I mean, it reminds, so in a way, sort of philosophically, this reminds me of the work of Scott Thrift. So Scott Thrift designed an annual clock because he wanted people to have a longer now. And what his annual clock does is it's one rotation of a clock that it doesn't have any lines. It's all a color wheel. So it goes from white all the way around again and through all the colors. So summer is yellow and autumn is orange and green is spring and up at the 12 o'clock is winter. And it takes one whole year to go around and you can't see it moving. But his whole concept was, I want to give people an experience of a longer now.
That's beautiful.
And so what I've realized from that work is that, every time we look at a calendar, we're looking at a box that represents a day. Our day, which is a gradient from, the sun going down, coming up, it's this continuum. It's really a circle. But somehow now when we look at, today, February the 8th, it's a rectangle. It's exactly what forced linear perspective has done to architecture. It's forced us to divide this day from that in this unrealistic. So who decided that 12 a.m. is the time, this arbitrary time when yesterday, it's now not yesterday, it's tomorrow already? Like, what?
It's architecture, it's Western, science, it's our world. I mean, there's my interest in to the question of time. I came across this. If you were to take a train from New York to San Francisco in the 1800s, you would set your clock 250 times because each town had a 12 noon.
Yeah.
And so even like what we think of as time, the time zones, it was just an agreement in 1921.
Yeah. It's all an agreement.
The other thing that makes you think, there's another book that I find really important. His thesis is that between 1250 and 1500, European man culture, they developed 5 things that were part of this hyper process of rationalizing. And so and I'm happy to say that perspective was one of them, but the other inventions were the mechanical clock, which gave us, this idea that there's 12 hours, you get the point. So the mechanical clock, the printing press, musical notation, Western musical notation, and the double entry business law.
Accounting.
Accounting. And so those 5 things were part of this sort of Western phenomena of trying to rationalize, measure, and it has a value. But when we miss those, when it prevents us from seeing nature's subtleties, is when we lose. The one thing that I recently learned about the reverse camera lens, they're actually being used. It's part of autonomous driving vehicles. So the lenses they're using are reversed because those reverse camera lenses allow the computer to take in more accurate data. So
they probably see more like we really see, not like how we focus our sight. I mean, if you're a good driver, you focus peripherally just as much as you do what's in front of you. That's something that we take for granted. I mean, we don't realize we're taking in all this information peripherally. We just sort of think that we're, and I think this is also the side effect of us being on screen so much, as everything is focused right here on this conversation, which for a podcast works great, but when you're doing meetings all day in Zoom, nobody gets up and stretches, nobody gets a snack, nobody uses the bathroom, everybody's focused in this box. And I think, like you said, it can be useful, but I think the reason why I think it's so important that we talk about this, and I know it's tangential to your mission, but I don't think it is really, because what is core about it is the idea that this has affected the way we build. And if you can see it everywhere, once you see this, you can't unsee it. And so to understand the paradigm with which all builders are building is an explanation of how we have the world that we're living in. And also something key and fundamental to understand about how we might trim tab or change the future of building and the future, because it's one of the largest impacts on the planet is how we build and how we live.
40% of greenhouse gases, and so it's
yeah, and it's not going to stop happening. People aren't going to stop building. So what's needed is a paradigm shift on a larger level. If we're going to not make it a luxury for the top 10%, this system-wide, ecologically holistic thinking needs to permeate all these spaces where people are building and making financial decisions, and the developers and all these different things. It's so fundamental.
I love your comment about the peripheral. It helps us understand So to me, I think this is what's the part of the power of Chinese landscape painting. It requires you to think in the periphery.
Yeah,
and you're absolutely right that there is the seeing the periphery, or being able to understand these more complex systems that Chinese landscape painting, to use as an example, kind of requires us to start to think about is absolutely essential to getting to retrofitting buildings or designing buildings or developments like village homes that incorporates the subtleties or these more complex parts of nature. So for me, to me it's very simple. It's if you start from this idea of projecting up geometry over nature or the system that prevents us from seeing the biology or these complex systems, that's perspective thinking, and that's kind of where everything starts from there, and it keeps us from designing in multiple systems.
Yeah,
I mean, just one other, for me, another example is this: that if you're thinking in Western perspective, which we so much do, the idea of parallel and perpendicular becomes the norm.
Yeah.
And I've seen many, many architectural projects where, like architects say, I would love to do passive solar, blah, 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 but the site isn't oriented right.
Right.
But so the idea that it's not oriented right, it's because if you think you have to put the building, parallel to the property line. And so the example of that house in Santa Monica, so we did something crazy so some of the walls are not parallel to the property line. And I literally did another project that's on my website that where, again, it's in Santa Monica. So I designed a building. It's a small apartment, and the major wall is 45 degrees from the property line. And the planner described it in her report as irregular geometry. And since it's my radio show, I can say well, this is crazy. I mean, your regular geometry is this accidents of history. Santa Monica just happened to be 43 degrees from south, but the sun should be the thing that we refer to as regular. The sun is...
Oh, I loved living in houses with odd angles. When I was growing up, we rented a house with a room that had a 45 in the room, so it was it was some sort of 5-pointed room, and I loved working with that because you have all these extra spaces. And for me as a creative, how I'd orient to my desk and how I could reach things, and just having that extra bit of room. And that's one of the things when you build with the geodesic dome. I mean, you don't have these flat walls in as many places to put your dresser against. So you got there's just, it's a different way of thinking, and I think it's so important that we start to free up our 45-degree angle on a property line. Most property lines in California now, they don't give you a large enough lot to build at not 90.
Well, the size is limiting, but also I see projects that are these huge, a building that's in the middle of a very large lot, and there's going to be lots of parking around it, and the building could have been oriented any way you wanted it to, but
Yeah.
it's just this, we habitually start with parallel, and
Yeah.
that's
It's
to me,
it's an assumption. It's a design assumption that we don't necessarily need to like ban, but we do need to like be aware of and like experiment out of, in a sense, because it is limiting our thinking, and it is causing us to make decisions that are nonsensical. Why you would build a building now that the heating and cooling system has to fight nature and the sun, the most powerful force we have. It's just mind-boggling, but that's myopia for you. And so I'm really glad that you pointed that out. Before we go, I wanted to talk about the development you did for Banning Ranch Park, because I think that's a good example of non-Euclidean design, in a sense, using some of these principles as well. And you had a very unique property that you were working with in terms of its history.
well, that's a project that's it's in a political limbo right now, but
Oh, too bad.
that project, there's some information on my website, was an extraordinary experience, particularly working with, trying to incorporate these more holistic ideas of the land, but also working with the Native American tribe, particularly a woman who's the spiritual leader of this indigenous people. And stay tuned. I'm going to post some more images from the architecture that I was very much inspired by working with her. A project that's built that I can also talk about that is also on my website, the Water Conservation Education Building. So there's some irregular geometry, if you will. And I could easily describe this because so we were working with an existing building that was completely geometry. Humans had nothing to do with the building. It was we call symmetrical in two directions, and there's a pyramid on it, and it was a terrible building for people. But they needed to we expanded the building. We cut some of it off, but because the building is a water education building, and it's located near Montclair, which is about 50 miles from downtown Los Angeles. But it's in the shadow of the San Antonio Canyon, which is the largest canyon that opens from the San Gabriel Mountains, which is a large, important feature in San Gabriel Valley in Southern California. But the erosion from the San Antonio Canyon has shaped both the geography of this region, because there's a alluvial fan that goes out, but also the water, the hydrological cycle, because all the rocks, and so this agency, it's a unique agency in that their mandate is to teach about water education, and also they part of a regional program to recharge the groundwater, the aquifer, and the
Great.
aquifer is very much shaped by the San Antonio Canyon. So one of the ways, the design of the building, so I'm tasked to design a building that teaches about water, and to teach about water, you teach about the hydrological, so the regional water things. And this I would attribute to my meditative thinking from Cubism and our Chinese. So I literally went up into the canyon to think about, how do I understand how this canyon shapes the region and this building. So I'm up in the canyon, and I actually realized a canyon's a very nice building entrance. So so the building entrance, the major feature of the building, is a miniature version of the canyon. So it's a canyon-like building entrance.
Oh, that's amazing.
And very much not regular geometry. So it's certainly an example of freeing myself from regular geometry to incorporate some natural ideas. And there's other elements of the building that is there to connect people to nature. I think there's a wind cooling tower, which I love. I placed a small window up really high in this tower, this wind cooling tower. You certainly can't see out of it, but that window is again, if you're thinking about how the sun moves across the sky, if you put a window in the right place, it brings in really like yellow, orange light through different times of the year.
That's nice.
And so the light quality from that window changes through the year. So it's just another way of increasing awareness about seasons and time.
Yeah, you took I don't know how to say it, but the city, but Hyderabad in India, ancient structures that had the cooling towers. Is that right?
Yeah. The Hyderabad has what they call wind scoops, which are stunning, stunning, stunning things. So the wind cooling towers are sort of historically from Persia,
Okay.
and I don't, that's they're both similar, but for whatever reason, Hyderabad, India, in that part, we call wind scoops, and it's probably something to do with a different strategy of capturing the wind. But the Persian wind cooling towers do that also. Anyway,
Well,
they're
and
both
some of the
really
Persian
amazing
ones, they
lessons.
go underground. Like there's these channels underground where the natural, like, because heat rises and cool
Yeah.
falls, and so they are using that cycle in the outside the building, under the building, to bring in air and
But so
exchange
so
air.
so so with a combination of the tower and then the basement that might have a water feature, but then pulling air through an underground tunnel before it goes into the building, so that below ground is going to cool the air off because it's
Because it's lower.
5 feet below. It's cooler.
Yeah.
It's whether it's 120 degrees out or 80 degrees, the ground is a constant 60 degrees or 50.
Yeah, that's
Uh,
great. It's air conditioning. It's
it's
passive air conditioning.
Yeah, it's and those things still work. They're 800 years
Yeah.
old and they still work. So I would say that they're a good example of resiliency.
Now you grew up you spent time as a child in Turkey, and you said
Yeah.
that really influenced. Tell me more about that.
Um, First of all, just I appreciate my parents. They didn't teach us to be afraid of the Turkish people. I mean, this is the late '60s. Um, but we went to see castles and sort of ancient ruins. So it's a direct experience of history, which I think is why I love history so much. But a
Mm-hmm.
specific example, there was a place we used to go camping on the Mediterranean. There was a castle on an island and a castle on the shore. We called it Castle in the Sea and by the Sea. Um, but on the castle on the shore, outside the castle walls, and these are not castles like in England. These are castles that have been destroyed now, as we know, earthquakes.
Mm-hmm.
Um,
Mm-hmm.
but there was in this one place, there's this field of rubble. And I have this image in my head. It was just this field of rubble with vines growing over it. My older brother told me that he said there, hundreds of years ago, there was a city of 1,000 people here. And so for me,
Wow.
this is why I think it's important to make buildings more efficient, because civilizations and cities, unlike what we think they do, they don't always just get better and bigger and more
Mm-hmm.
orderly. They
Mm-hmm.
collapse. Cultures collapse. And for me, that lesson is seared in my head that, we might fantasize that our buildings will always be here, or our cities will always be here, or we'll always be here. But the truth of it is, it's not. And so that's,
Mm-hmm.
thank you for that. It's a really, really profound lesson. It's not something you read in a book that cities collapse like Rome, but like really as a 7-year-old, like, oh, the city is rubble now. And
Yeah.
now we know from Turkey is the earthquake in Turkey is
Mm-hmm.
strikes home. Um,
It's a reminder of, and it's so hard to, when you look at things like that historically, there's this detachment, but when you look at it in the news, it's so much more affecting. It seems so much more real, but these things were real for people
yeah.
in ancient times
Yeah.
as well.
Yeah, I'm sort
And
of meandering here. Now with COVID, we're starting to realize, we now know that corporations are letting people stay at home to work. So New York and San Francisco is not as crowded. Again, since I love history, and another thing I came across that so Rome is probably notable for the first city of more than 1 million people. And I think in the
mm-hmm.
height of Rome, it was close to 2 million people,
Mm-hmm.
certainly more than 1 million. But with the collapse of Rome, the Roman Empire in the 350, 400s, 450, Rome became less people. But so the reference point is in 1515, which is when Michelangelo, Leonardo da Vinci, and Raphael were all in Rome doing great art. The population of Rome was about 35,000 people.
Oh, that's it.
So this is an image I have in my mind that you have, 35,000 people wandering around this fabric that once held 1 million people. And so I mean that's certainly not an example of solar punk future, but it's an example of what could happen.
Yeah.
Um,
Well, I think that's a good place to leave the conversation. This idea that what we build, some of them last, 800 years, and some of the things what we build is it'll collapse. And so we need to think about what kind of world we're going to build and know that this perspective that is centering around these assumptions we're making really deserve to be relooked at. And I think your mission is speaking to a very practical part of what can be done to reduce energy and to make a more sustainable future. And it's something we would hope that more people would know about, and more people in your field and other related fields will begin to adapt. So why don't you close by telling me how people can find you, how people can find your architecture firm, and what are you looking for help with on this project ongoing? Is there certain needs that you have of people that you would like to meet who can collaborate with you or be in conversation with you about these ideas and how to share them?
well, thank you, and thank you for this wonderful conversation. And on the air or off the air, hopefully we'll continue.
Yeah.
So my website is, without any breaks, just Carl Welty, Welty, Carl with a C, carlweltyarchitects.com. My email address is carl.welty.art@gmail.com. What looking for with my mission is people who, if you know people who have a concrete building in California who want to become more energy efficient and more cost effectively and more resilient, would love to work with people to retrofit buildings. And our agencies are, companies who own many of these buildings, open to talk about how to do that and make their buildings, retrofit their buildings so that they're really viable and more usable with landscape and architectural, employee beneficial, nice spaces, but spaces that provide energy efficiency. So looking for people who are interested in repurposing their buildings so that they can be a useful part of our smaller carbon footprint for the next 100 years.
Good.
And just a closing that, all these lessons from ancient history, those buildings, some of these systems are still around and they still keep things cool for after hundreds of years. So if one needs examples or evidence of how resilient they are, there are plenty, and they provide a beautiful lesson on how to build a reduced carbon future. And they demonstrate this because they were built before carbon was an issue. So if we can learn lessons from carbon-free cities from 2,000 years ago for how to build cities that are carbon-free in the future.
Man, I'm ready to end it there, but I hear someone shouting, "What about concrete? Concrete is a carbon heavy."
Well, one thing I'd say is, so by using existing buildings that are concrete, I think there's additional benefit of leveraging that concrete to make those buildings more efficient without tearing them down.
Leveraging existing concrete.
Yes.
And also upcycle.
There's other ways to provide that thermal mass. But if I were to build a house for you and we use the concrete slab for the thermal mass, yes, there's a carbon footprint. But if that carbon, the embodied carbon in that concrete slab helps you reduce your energy requirement, by a lot for 100 years.
Yeah.
Permanently, then you certainly would offset that carbon, the embodied carbon in the concrete. Which
One
again,
of my favorite lyrics, everything counts in large amounts. So invest now, save later, on and on and on every month, every month. And that's I think that's what it's all about, is making these systems thinking decisions in the wisest ways possible, and not just making these really narrow decisions based on very narrow criteria or assumptions that we don't know we're making, like, perspective and parallel.
So using the example of the concrete, if we only look at concrete as this structural element and it has a large carbon footprint, which it does, but people are inventing concrete that doesn't. But it does, if we, invite people to think about that concrete as part of an energy system, and that changes the calculus.
Yeah, same thing as the fountains. It's like the net energy of all forms of energy is causing the plants to thrive. You can't just cut down all the plants. You'll have no water cycle, right? Plants take water and we don't have water. It's like, got to get out of this lack mentality of thinking that everything's scarce because nature is abundant. We just need to start working with the north and where the sun's coming in, where it's not coming in, where the trees are, where the nature is, and start to see things from that camera with the peripheral perspective.
I think if we start looking at the world like a Chinese landscape painting, as opposed to starting with the geometry laid over the landscape, systems that seem to be hard to figure out how they work together, it's easier to understand it if we free ourselves from that grid.
What if we focused on the harmony and a little bit less on the order? Let the order be in order. Create harmony.
That's beautiful. It's not looking through the grid helps us see the harmony of these systems.
Yeah.
I guess I would add to that.
Beautifully said. Carl Welty, thank you for joining me on the Spaceship Earth mission log. Really enriched by your ideas, and I'm so glad that you shared all these things with me. I learned more about cubism than I ever knew. And I think it's a strange practical application that I didn't even realize. So yeah, as we learn to be Trintabs together and we learned how to be parts of the whole, to see these multiple perspectives and how they fit together. My hope is that you all take your own unique thing from this and you do what you do. And you now come enriched with a conversation about architecture. Spaceship Earth Mission Log on Substack. It's on YouTube as well. And my podcast, The Language of Creativity. Maybe we'll have to have you on talking about Cubism and Chinese art and all of these perspectives.
I would love that. Yeah. You mentioned a couple of things that enriched me. You actually see a painting behind me, which is... But a lesson from Liszewski is a meditative painting process I experienced as part of this early exploration of nonlinear thinking. And so I had a really profound experience of not trying to design through perspective or geometry, but through this dynamic use of symbols.
Shout out to Stoopy from the Design Science Studio, who's always playing with the geometry of the octahedrons and all the different shapes and the motion of those and how they expand and collapse. Shout out to Buckminster Fuller Institute for the Space Camp. And also, I also think of the work of Kurt McNamara as well, who's doing so much work on understanding Bucky's sense of geometry, which is not in squares. Wonderful to have you on, Carl. Thanks for being here.
Thank you, Stephen. It's been really fun, and look forward to talking more about the world.